Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to calculate a solution's molarity. So let's get into this. So the first thing we need to start with is, what is molarity? Well, molarity is a measurement of concentration that is commonly used in chemistry, and it's defined as in the following way. First, it's represented by the capital M, and a lot of times that M might be italicized, but here I have capital M. So capital M is equal to the moles of the solute divided by liters of the solution. Now, solute, what is solute? Solute is whatever's being dissolved, right? So I have moles of the substance that's dissolved, and the solution is basically the solvent and the solute together. The solvent is what's doing the dissolving. So I want to get the liters of the solution, which is the solute plus whatever the solvent is. Most of the time, it's water. Okay, so if I can get the moles of the solute and the liters of the solution, then all I need to do to get molarity is divide them. So whatever problem I'm given, I need to make sure that whatever unit of the solute they're giving me, I need to convert that to moles if it's not already in moles. And whatever volume of the solution they're giving me, I have to make sure that's converted to liters. So let's go ahead and start with the first problem here. So we're told a solution was made by dissolving 8.20 grams of phosphorus sodium phosphate in a total of 100 milliliters of water. So then they're asking me, what's the molarity? So again, I need the moles of the solute and I need liters of the solution. So what do they give me of the solute? So I'm dissolving what? I'm dissolving 8.20 grams of the sodium phosphate. So the sodium phosphate is my solute. That's what's being dissolved. I need that in moles. What did they give me? They give me grams. So I'm going to have to convert grams to moles. So I need the molar mass of the sodium phosphate to do that. So that's the first thing I want to do. I want to convert that to moles. So I'm going to take the 8.20 grams of the sodium phosphate. So that's Na3PO4. And I'm going to use the molar mass to convert that. And so the molar mass of sodium phosphate is 163.9408. So 163.94.108. Let me double check that again. 9408. So 9408 grams of the sodium phosphate. And that means 1 mole of the sodium phosphate will be on top. So grams of the sodium phosphate cancel out. Now I have moles. So all I need to do is calculate that out, and I get, what is it? Oh, here, let me calculate it out. 0.050018. Okay, so I have 0.050018 moles of the sodium phosphate. Okay, now I have moles of my solute. I need liters of my solution. Now here they're giving me milliliters of water. So basically what they're basically giving me here is water is actually the solvent, but here I think we can assume that this is going to be the volume of the solution itself. So let's change this to, instead of water, to make it more accurate, it should be milliliters of solution. Because water is a solid. Let me double check. Yeah, so volume of 50 milliliters down here. So we've added enough water to get 100 milliliters of the solution. So this is the volume of the solution, but we need that in liters. They gave it to us in milliliters, so we're going to have to convert that to liters. So we take the 100.0 milliliters of solution and we use our conversion factor. So 1 milliliter is equal to 10 to the third, or 1/1000th of a liter, or 1 liter is equal to 1,000 milliliters. Either way works. So here I'm going to do 1 milliliter on the bottom and 10 to the negative 3 liters on top. So milliliters cancel out, and when we calculate this, we get 0.1000 liters. So now to get the molarity, all we need to do is take the moles divided by the liters. So we get 0.050018 moles divided by 0.1000 liters. Now, for the sig figs here, we need to go back here. And so this is the least number of sig figs. So really, we should have this 0 is the last sig fig, but we're keeping the extra digits here. So that 0, I'll put a line under it, is the last sig fig. So when we calculate this, we get a molarity of 0.500. Molar. And you'll see that this has 3 sig figs. Why? Because when we're dividing and multiplying, our answer should have the same number of sig figs as the least number in the numbers that we're multiplying and dividing. Here, this has 4 sig figs. Here we have 3, because again, we're stopping at this 0. And so our answer should have 3 sig figs. So that is the molarity of this solution. Let's do the second problem. So here we're told that a silver perchlorate solution was made by dissolving 29.993 grams of pure silver perchlorate in a total volume of 50 milliliters of the solution, right? So what is the molarity? Once again, molarity is moles of solute divided by liters of the solution. So if we're not given moles and we're not given liters, we need to convert to those units. So here, once again, we're giving grams of our substance, not moles. So we got to convert that to moles. So we're going to take the 29.993 grams of the silver perchlorate. Oops, that should be Ag, not Al. The silver perchlorate, I can't write today, ClO4 over 1. And we're going to use the molar mass, and the molar mass is 207/3176. So 207, did I say 3176? 3176 grams of the AgClO4. That's equal to 1 mole of the AgClO4. So grams cancels out, and when we calculate that, we get 0.14461. Okay. Let's write that down. So 0.144671. Let me double check. 144671. Let's go ahead and put 75 in there. All right, so that's what the calculator gave us. That's moles of the AgClO4. Okay. Now, as far as sig figs go, we need our answer here should be have the same number of sig figs as the least number. Here we have 7. Here we have 5. So we should cut it off at 5. 1, 2, 3, 4, 5. So I'll put a line there. That's the last sig fig. We're going to have to use that later for our molarity calculation. Now, for the volume, we're given the volume of our solution in milliliters. We need to convert that to liters. So once again, we're going to have 50.00 milliliters. And we're going to multiply that by the conversion. So we have 1 milliliter on the bottom, 10 to the negative 3 liters on top. Milliliters cancel out, and when we get that, we get 0.05000 liters of the solution. Now all we need to do is take moles divided by liters, and we got our molarity. So 0.1446717. Again, line under the 7 to indicate that that's the last sig fig for that measure. And then divided by 0.05000 liters. And again, this is moles. And we calculate that, and we get 2.8934. So 2.8934. So this is equal to 2.8934. Let me double check. 2.8934, and then 35 to add a little bit. Okay, so now what's the number of sig figs we can keep? So here we have 1, 2, 3, 4, 5. We have to stop there because that's the end of our sig figs. So we have 5 sig figs here, and here we have 1, 2, 3, 4. So 4 is less than 5, so we need to keep it to 4. So 1, 2, 3, 4. We cut it off there. So this is a 3. The 4 is the next number is a 4, so we keep that a 3. So the final answer is 2.893 molar with a capital M. And that, ladies and gentlemen, is how you do molarity. That's how you calculate molarity of a solution. Thanks for joining me. If you enjoyed this video, if this was helpful in any way, then please like the video, hit that like button, share the video with your friends. Please subscribe to my channel. Make sure you click on the notification bell. And when you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem you want me to go over for you, or a question you want me to help you answer, or if you have a topic you would like me to cover, I would love to do that for you. Thanks for joining me, and have a great day.